This is a pre-built version of the application. So if we go ahead and run it, so the implicit constraints that we have here is that adjacent regions must have different colors. So the variables are regions or state here, and the values are colors for those different states. And the domain or the colors that are allowed are those for different colors. And the solution have a list of variable equal value, so state equal color assignments satisfying all constraints. And we will be using the backtracking search, so it will be depth first search plus considering the assignment to a single variable at each step, and considering only values which do not conflict with previous assignments. And we will be ordering the states from most constraint, so having the most number of neighbors, to least constraint, having the least number of neighbors. And the derived list of implicit constraint is that this state must have different colors from those neighboring states, and this one must have different color from those neighboring states, etc. And we end up with this color assignment solution. So this state have this color, and its neighboring states have different colors from this one. And same for this one, its neighboring state have different colors, etc. Till we get here, it has different color from its neighboring state. I will start by creating a new project. And here we will have this class which will contain the constraint satisfaction problem, map coloring logic, and this will represent a variable, so a state in this case, and this one represents a constraint between two that must have different colors, and this one will contain a main method and will be driving the application, and this will have the data, so the list of states and their neighbors, and this will be a display helper. And we will be using this hard-coded data, so we can specify if we are gonna use either 3 colors, 4 or 5 colors for the different regions, for coloring the different regions. And we can either do the Australian state coloring, or US states, or the Schengen area states. So we'll specify what we will be using here. So here we'll be using the Australian states and try to color that map with 3 colors. And a variable or a state in this case will have a name and a list of neighboring states, and those will be initialized in the constructor, and it will have a list of constraints and get methods for those 3, and the toString method will return the name of this state. And a constraint will have the names of 2 states that must have different colors, and a list of those 2 states, and those will be initialized in the constructor, and we'll have get methods for those, and the toString method will return the name of the 2 states that must have different colors. And we will need to compare constraints against each other. So let's go ahead and generate hash code and equals method, and we'll base those off the names of those 2 states in this constraint. So let's rearrange this code. And we'll need this method that takes in a map containing states and their assigned colors, and we take a look inside that map and check if it contains the name of the 2 states we have in this constraint, and if it does, then we make sure that they do not both have the same color. And this code displays the solution and the derived list of constraints and the initial information and the variable constraints and the variables. And we'll keep track of the list of variables, states, and the display helper. And we'll initialize both of those in the constructor, and we'll display the initial information and the variables. And we'll have get methods for those 2, and those 2 static methods will populate the variables and the constraints. So the variables are populated based on the data coming from here, one of those three. So we specify it here to be this one, and we'll be using three colors here. And let's add this verbose flag, so we can run the application in either verbose or default mode. And we use populated list of variables in order to populate the constraints. So we check the neighbors for each one of those variables, and based on that we derive the constraints and return an array list containing those derived constraints. So we instantiate the class containing the constraint satisfaction problem logic, passing in a new display helper instance and a populated list of variables. And we use this instantiated display helper in order to display the constraints that are returned by the static populate constraints method. And if we are running in verbose mode, then we go ahead and display the variables. So let's go ahead and test run the application before finishing up the code. So this is the variables for Australia and their neighboring states, each state and its neighboring states. And this is a derived list of constraints. So those two states must have different colors, etc. And those states must have different color from this one, etc. And this method checks to see if color assignments are compatible with constraints associated with all variables. And this method does backtracking search color assignments, so it takes in a map of current assignments, so each state and its associated assigned color, and returns an updated map of color assignments. So if we successfully assign compatible colors to all the state, then the return assignment will be the current assignment that is passed in. Otherwise, we pick up a state that hasn't been assigned yet, and we loop through all the colors in the domain, and we instantiate a temp assignments map based on the map that is passed in, and we assign this variable a color and put it in this temp assignments map. And if we are running in verbose mode, then we go ahead and display this information. And if we find that all the assignments in this temporary map are compatible, then we do a recursive call on this method, passing in the temporary assignments map, and try to assign a new state, a color. And in case we assigned the colors to all the states, then we will return assignments, which is null. So we'll skip this logic. So if new assignments is different than null, then we return what is returned from here, and break out of this loop. And this should do it for this class. And here we make a call to the backtracking search assignments method, and pick up the color assignments map. And if it is null, then we indicate that no color assignment solution has been found. Otherwise, we display the solution. So this should do it for this class. And let's do one last thing. Let's remove this one from here. And let's go ahead and test run this. So we are running in verbose mode. So this is the list of states and its neighboring states, and we have them ordered from the one with the most neighbors to the one with the least number of neighbors or no neighbors. And we end up with this derived list of constraints. So this state cannot have the same color with any of those 5 states, and same for this state, cannot have the same color with any of those 3 states, and this one cannot have the same color as this one, and this one cannot have the same color as this one. So we start with assigning this color to this state, and then we assign this color to this state. So those 2 states will have the same color, so we cannot do that. So we assign a different color, and now those 2 states have different colors, so we proceed to the next one. We assign this color to this state, but we cannot do that since those 2 states are neighbors. So we assign a different color to this one, and we also cannot do that since now those 2 states have the same color. So we assign this one this color, and now we are fine since those 2 states have different colors, and those 2 states also have different colors. So we proceed to the next one, etc. until we assign colors to all the states, and we end up with this color assignment solution. So here we have a binary constraint graph. So the arcs represent the constraints. So those two states cannot have the same color, and those two cannot have the same color, etc. And the nodes represent the variables or the states. And let's do one last thing. So let's go here and change this one and go with Schengen area, states in the Schengen area, and let's use 4 colors for that. And let's run in default mode. So here we go. So we have those 4 colors in the domain, and we have the states ordered from the one with the most number of neighbors to the one with the least number of neighbors, or no neighbors in the Schengen area. And we end up with this derived list of implicit constraints. So Germany cannot have the same color as any of those states, neighboring states, and same here and here, etc. And we end up with this solution, color assignment solution. So here we have this color, and none of its neighbors have the same color, and same for this one. None of its neighbors have the same color, etc.